Hello, welcome to the live stream of Launcher 1, which will be launching the mission called Straight Up. Happy that you're here, and hopefully we'll get to see a successful and on-time launch today. Launcher 1 is, of course, Virgin Orbit's vehicle, new vehicle, relatively new. It's only its second commercial flight. I think it's its fifth overall flight. It had a couple tests to start. And yeah, we'll get to see this Launcher 1 vehicle fly today. We'll get to see some of the unique things about it, because it's actually a very unique rocket in the rocket industry right now. And yeah, we get to learn a little bit about comparisons between different rockets and what's going on in the rocket industry today. And hopefully, also, we'll get to see some really cool shots of this rocket flying off into space. So let's get into it. Just to give you a bit of the timeline here, Virgin Orbit is targeting a takeoff of the plane. Yes, I said plane, not rocket. This rocket launch is interesting because it actually starts from a plane. So the plane will be taking off in around 20 minutes or so. I think a little bit less than 20 minutes. And then basically once the plane is in the air and gets up to its target altitude, it'll be releasing the rocket sometime after that. It'll probably take about 20 to 30 minutes after that. So that's relatively what the timeline is. Yeah, so it's gonna launch from the plane in probably roughly 50 minutes or so. Although these things are not quite exact with Launcher 1 because it is flying from a plane, so the launch time can vary a little bit. They have a 2-hour launch window that starts a 2-hour launch window that starts in 10 minutes. So basically any time from 5:30 UCT to 7:30 UCT. So basically almost just over 2 hours from now, it would be the end of the launch window. So that's the timeline for the launch. It's going to be basically a launch that starts with the takeoff of the plane, though, and that's happening relatively quickly. It'll be just in over 15 minutes here. So we'll be definitely tuning into the live stream to see these key moments. But first, before we start doing that, I just want to kind of go over some of the things that we should be seeing in this vehicle and some of the things that are different about this vehicle and why this vehicle is unique. If you want to see the actual Virgin Orbit live stream, you can go to the Virgin Orbit's YouTube channel. I think they should have the stream available there. That's the one that we're going to be looking at for the key moments in this whole launch. So if you're looking for that, you can definitely go there and see that stream. Without further ado, let's get into what makes this vehicle special. So first up, we have, of course, the Launcher 1 vehicle, which is launching from a plane. And which plane is that? It's the Boeing 747. So they've basically reconfigured this Boeing 747 to be able to carry the rocket underneath its left wing, as you see in the left part of the image here. So basically it'll just sit there, kind of like a missile on a bomber or something, but it's not anything dangerous. Don't worry. It'll sit underneath there from the start of the launch all the way up till it gets up to its target altitude, and basically it has a deployment mechanism that basically drops it, and then as soon as it's been dropped, the engine will ignite, and then it'll take off and shoot off into space. And it has 2 stages, as you can see. So it has the first stage, which is the fatter part of the rocket, and then it has a second stage, which is the thinner upper part of the rocket. And it needs both of those stages because it still has a lot of delta V even when you launch from the plane in order to get up to that orbital speed. The actual speed of the plane is not actually the real reason and ultimate kick that the rocket is getting from launching in the air. But we'll talk a little bit about more about why launch from the air is important and what the actual implications of that are, because there are some interesting things you can take advantage of besides just the velocity of the aircraft that you have when you leave. But just to give you an overview of the key moments of the launch to look out for, I've kind of put together a little bit of a diagram here. So to start off, we're going to have the takeoff, which is going to start, obviously the plane will be on the ground and it's going to take off from the runway just like a regular plane. Nothing too complicated there. Then it's going to get up to its launch altitude, which is going to be right around 10,000 meters or so. And basically this is where the the rocket will be able to take off from. And that's where we're gonna, basically the rocket will be dropped from the 747 once it reaches that target altitude. And that initiates the ignition and launch sequence, where the rocket will basically be ignited and it'll be allowed to shoot off into the, in front of the 747. You'll see it kind of shoot off in front, and it'll start to climb up into space. Then finally, after some minutes, you'll have the main engine cut off. So that booster will run out of fuel. It'll shut that engine off. Then it's going to separate from the second stage. So the second stage will be separated from the vehicle. And then finally, that second stage will be ignited. And that's the stage that's going to carry the vehicle, the rest of the payloads anyway, the rest of the way into space. So there are kind of a lot of steps in this one, but this is basically what's going to allow Virgin Orbit to get their payloads into orbit as efficiently as possible. So this is kind of the whole idea. A little bit about the rocket itself. It's being powered by basically these Newton 3 and Newton 4 engines. And basically what it's doing is, in order to control itself, it's using what's called thrust gimbaling. And you can see how that's kind of happening on the screen here with the white circle with the black dot on it. That's the engine, as it's basically moving a little bit. And you can kind of see in the other pictures how the stream of the exhaust is being moved side to side. And this is basically the mechanism that the rocket is using in order to control itself once it's been dropped from the vehicle. So this allows it to maneuver and get itself on exactly the right trajectory so it can reach space. So those fins that are on the back are not actually being used for controlling the vehicle, more of a passive stabilization. It's the engine gimbal that's actually allowing it to control itself on the way to space. So keep that in mind as well. Another interesting thing about the Newton 3 and the Newton 4 engines is that they are both gas generator engines. This is pretty typical in the rocket industry. So basically, it just means that it's taking a little bit of the fuel on the oxidizer, and it's actually pumping them into the pre-burner, where it creates a little bit of energy that can be used to spin the turbine that runs those pumps. So it's kind of like a self-feeding system. It's not the most efficient system, but it tends to be one of the cheaper ones that a lot of the commercial rockets tend to use today. I think it's probably the most common cycle. And yeah, it'll just dump those extra gases that come out of the preburner overboard. And you can kind of see on the picture on the right here how you have the main nozzle that's shooting out the exhaust, and you kind of have this secondary smaller nozzle. It's not really a nozzle, but it's basically getting rid of those exhaust gases. They don't produce a ton of thrust, so it usually is not something that's like destabilizing the vehicle. Just to give you an idea of the comparison of this rocket versus other rockets, you can kind of see here the main stats of the vehicle. It's actually quite a big vehicle, considering that it's going to be launching on a plane. So keep that in mind. Here, I just want to go back to the mainstream a quick second here. Here we go. So it looks like we have launch coming up here in just a little bit. This is kind of the series of events that's going to happen for the straight up mission. You can see them on the screen here. And it looks like they don't really have a predicted launch time just yet, so we'll see how that goes. But you can see here that there's quite a lead up to the actual launch itself. It doesn't, because it's going through all these phases where it has to launch the jets and take off and get into the air and actually launch the payload. It takes from the actual launch of the plane, it's going to probably be about like an hour or so. So yeah, we'll keep up to date on what's going on. The plane's still on the ground, so we're not like super close to the launch yet. It's definitely gonna come somewhere though in the next 2 hours, because that's their launch window. Once the launch window closes, then they won't be able to launch anymore. But yeah, going back to the rocket, we were just talking about the stats of the vehicle here. So you can see vehicle still on the ground. You can kind of see how it's connected to the plane as well. So it's just sitting under the wing there, and it looks like basically like a giant missile, which is essentially, I guess, what it is. It's just flying to space instead of a target somewhere else on Earth. And basically, yeah, the red piece here is what's carrying the rocket, and that's going to be the release mechanism that will eventually drop it. But the thing here is that they have to actually fuel this thing on the ground, right? So usually rockets, they get fueled right up to the point when they're about to launch, and then they can just kind of release the fuel line and let it go. But this one's a bit different because they actually have to fuel it like on the pad.
Hey everyone, and welcome back. Alex, can you tell us a little bit about why we're launching at night this time?
Sure, yes. So we're actually launching at night this time to practice. We're practicing this for our next flight. So this particular one, there's no requirement that's requiring us to do it at night, but on our next flight, our customer has a requirement. They call it local time of ascending node. So the satellite is going to pass the equator as it's going in its orbit, and they want it to happen at the same time of day every time it passes it. And so in order to do that, we have to launch at a very specific time. So for the time that they want that to happen, it means we have to launch at midnight for where we're launching from.
Amazing. And we'll be carrying 7 payloads into orbit tonight. Can you, for those that may not be initiated, define what a payload actually is?
Yeah, you might hear us a lot tonight say payload, and so what we're referring to is our customer satellites. So a lot of engineers will refer.
Don't worry, you guys are already initiated. We know what a payload is, right? So yes, they're going to actually be launching the night, like they said, practicing for what they call a sun-synchronous orbit. That's basically where like they said, the satellite will come in front of the Earth at exactly the same time every day. And to get into those orbits, you have to launch at a very specific time. So I guess they want to practice for doing that future kind of mission. So yeah, they're going to launch in the dark. I'm not really sure what the technical challenge would be of launching Launcher 1 in the dark. Basically, everything's automated on the launch vehicle, so it doesn't care if the sun's there or not. It's doing most of its work just based on like positioning and GPS satellites and stuff. So, but yeah, I guess they got to practice, right? Just coming back to the vehicle stats though, basically we have the entire length of the rocket is about 21.3 meters. So it's quite long for a small sat launcher, and especially when you consider that it's actually like going underneath a plane. So the plane is carrying this entire thing. Which is like a significant percentage of the length of the aircraft. The diameter of it's also quite large at 1.8 meters, which is more than most smaller sat launchers, so definitely interesting. The takeoff mass is, of course, the 30 tons, which again is much bigger than a lot of small satellite launchers. And it has quite a capability as well, with the 500 kilograms to low Earth orbit and 300 to sun synchronous. So it's really quite a capable rocket, and definitely has some interesting specs considering what's going on. I also would like to kind of compare this a little bit. So, you know, what are some rockets that are in the neighborhood of the Launcher 1's launch capabilities? You can see here, I'm comparing the Launcher 1 with the Electron, which is another rocket that's a small sat launcher. And it has similar capabilities, but slightly different design. So Electron is kind of built out of carbon fiber, so it's much more efficient mass-wise. Launcher 1 is mostly made out of aluminum and metal, so it has less efficiency in the mass, but it more than makes up for that by being a much bigger beast. So you can see that Launcher 1's a bit taller, it's definitely wider, its mass ends up being about 3 times more than Electron, and the thrust is not 3 times more though, and that's because it's flying from the air, so it doesn't quite need the really big thrust at the start of the phase in order to get into the air like the Electron does. So that's one advantage that it takes in order to have a lower thrust to mass ratio. It also gets a lot more payload into orbit, almost twice as what the Electron can do. But of course, for that extra payload, it also costs more at about 12 million to the 7.5 million of the Electron. interestingly, the amount of money you have to pay per kilogram is almost the same on these two vehicles. So in the end, even with these different designs, they kind of ended up in a place where it was basically the same. So I wonder if they actually struggle to fight with each other for payloads and stuff. I suspect they will be quite competitive with each other in the future, considering the somewhat equivalent price point that they're dealing with. The one advantage that Launcher One will have is that basically they can fly to pretty much any orbit just because they can fly in a plane and go anywhere. Electron is kind of restricted to launching in New Zealand right now, and eventually in West Virginia as well. But right now it's restricted to New Zealand. So there's some orbits that it just can't go into. Whereas Launcher One can just, fly the Boeing 747 somewhere else and launch from there. So that's one huge advantage to launching from a plane, is that basically any orbital inclination is available to you as long as you can fly your plane there and launch from a lower inclination or something. Yeah, so if you guys have any other questions about what makes a plane launch better, please let me know and we can definitely address that. There are a couple other things that I haven't mentioned yet that I'll get into later, but for now, I'd like to quickly talk about some of the payloads that are on board the Launcher One. So first up, we have the one solitary non-military payload. So they have roughly I think it's 6 or 7 payloads on this thing, so it's quite a busy rocket. But this one is one that was built by the University of Colorado, and it's specifically designed to measure the radiation that's coming off the Earth. So basically, Earth produces radiation because of its heat. And I think they're trying to use that data or find that data in order to better calculate things for like weather and climate and things like this. So monitoring global warming and stuff. So that's one satellite that's going to be on there that will not do military things. Unfortunately, the rest of them are kind of military type payloads. So yeah, their names are Lone Star, Mizar B, Nachos 2, Recurve, and Slingshot. And basically, they're doing a bunch of different specific tasks where they're going to be looking at communications and tactical support and things like this. The details on these are not super clear, and of course, there's a reason for that. These things are slightly classified, what's actually going on inside of them and stuff. So yeah, that's just the nature of dealing with military payloads. But yeah, they'll be going into operation as soon as they have a good launch. So yeah, we'll see how that goes. I'm mostly interested in the non-military payload though, to be honest. Yeah, mapping out the radiation of the Earth is definitely an interesting task, and it will definitely give us more insights about things to do with like global warming and climate change and stuff. So I'm always curious about new data in that field. All right. So that's a good overview of the payloads that are on board the vehicle. And yeah, let's switch over to the mainstream and see where they're at right now.
And they really won the first competition that we ran on our OSB-4 contract, which was deliberately set up to bring in a whole crop of innovative new launch providers. And today's launch will be the first in a series of 3 launches. So we look forward to successfully completing all 3 of those. Beyond that, we tend to compete our launches one at a time, and I expect Virgin Orbit will continue to be a strong competitor for those launches.
We're definitely planning on it, sir. Well, thank you so much for your time, Lieutenant Colonel Belts. We're really happy to have you here.
My pleasure. Thanks, Danielle.
And back to you in the studio.
Thank you so much. Stay tuned for more customer interviews coming up, but in the meantime, we polled our audience on Instagram and Twitter and asked what questions you had about our rocket launch. We're going to hear a few of those questions now. Alex, do you think you'd like to take a stab at the first question?
Sure, yeah, let's do it.
Okay, great. Our first question is coming from Cooper in Los Angeles, California.
Why do we need more satellites? Why can't we just use the ones we already have?
Hey, Cooper. So we want to put more satellites in space to make life better here on Earth. So newer, more advanced satellites could do things like maybe track a wildfire live, track the weather, track climate change, or provide faster internet, better communication. The new idea now is to send up cheaper, more advanced, smaller satellites into a low Earth orbit. They actually won't stay in that orbit very long. They'll enter in a few years, and then we can replace them as needed. But it's almost like, keeping a cell phone for 10 or 15 years or getting a new cell phone.
It's a little curious what's going on with the launch clock here. Right now it's showing T-minus 6 hours, but I think that I don't know exactly if that's showing the proper time or not, or if it's actually supposed to be T-minus 40 minutes, because there's nothing on the Twitter page or anything about a delay. So,
rockets don't usually fit on the airplanes we fly on. We had to do a lot of work on our Cosmic Girl airplane. We installed an underwing pylon so the rocket doesn't travel inside the plane but on the outside below its wing. And we give the rocket a ride to the sky. Then we release it, and then it turns its engine on, and then it flies to space at 17,500 miles an hour.
So that's Richard Branson. He's the, of course, the founder of the company and the main investor. He's the one with all the money. So the plane is still on the runway here, and we're expecting it to launch probably in the next 10 minutes or so. That will put it in position to be able to perform the drop. So yeah, we'll be expecting that coming up pretty quick. So yeah, it's going to take off just like a normal plane. The only difference being that it has that rocket under its wing. And unfortunately, I can't really tell if they're still fueling it, but you can kind of see the engine. We're looking at the back of the plane right now, so you can see like the engine bell sticking out there, just on the bottom left-hand part of the screen there. But I think their fueling is complete, so that should be good, because those are the fuel lines that are sitting out there. So they've left that part of the phase. They got this like elevator music in the background. Man. So yeah, just to speak a little bit about the capabilities of the 747 in terms of its ability to get something like this off the ground. The 747 has a total payload capacity on takeoff of like 124 tons in just a normal configuration. So it's more than capable to get the Launcher 1 into the air, because Launcher 1 only weighs about 30 tons. So it's definitely 100% able to do this, no issues. The next thing that's interesting about the Boeing 747 is that it has like 4 engines and a giant tail fin. And that helps in terms of balancing the aircraft, because of course we have this like heavy thing on the left-hand side of the aircraft, 30 tons on the left-hand wing, but there's nothing on the right-hand wing. So doesn't that kind of cause the plane to kind of like
tip over?
Well, kind of. Actually, that's kind of what happens. The thing, though, is that the plane can compensate for that imbalance in the weight by using both its tail fin, which will basically turn in order to create more drag on the light side of the aircraft. It will also use its ailerons in order to help balance, and it can also use the 4 engines. So basically, it can turn the right engines like to a lesser throttle, which will basically help to balance out the aircraft. So that's why the Boeing 747 is really good for this, is because it has lots of buffer in all of these systems to be able to play around with those things. And it can respond quickly to when they also drop it and then put everything back to normal. So that's kind of the reason why the 747 has been chosen as the aircraft for this. And it's been performing these types of missions for other launches as well. There's a vehicle called Pegasus, which also was an air launch vehicle, and it also had a similar type of launch profile as the Launcher 1. But here, this is an interesting thing on the screen right now. You can see the fueling, I think, levels of each of the stages. I think the first stage is still fueling up here, based on what they showed there. Looks like it's not quite filled up yet. Of course, the main difference here being to other launches is that the plane can't take off until the rocket is fully fueled. So there's no fueling like in the air. At least I don't think there is. That would be an interesting optimization where they would take some fuel in the plane and like continually fuel in the air. I'm not actually sure if they do that. They might actually even do that.
On S1 locks fuel DP.
Okay, I think that was the fueling. So this is the runway now. Although it's really tough to see. This is the one disadvantage of launching in the night is that, you know, the live stream is a little bit less spectacular for the plane launch anyway.
Wow, everyone, this is super exciting. So obviously, as you can see, Cosmic Girl is going out to the runway, and she should be taking off very soon. When we had that backside view, you could see her checking all the flaps. You can see her checking the tail flap, so that was super cool. So we're going to both watch and listen as she makes her way out.
So the next interesting thing about
the takeoff time, as it shows on the screen, is expected for 10:50 p.m.
So we're just 2 minutes away from liftoff.
Take about 69 minutes, so just over an hour to get to the drop point when she does that.
Another interesting thing
That's
about
such a beautiful shot, watching Cosmic Girl taxi over to the runway.
And this is our first time seeing it at night.
I'm not sure what's so exciting about the night thing, to be honest.
About what's going to happen once she is up in the air. There's a couple of things that I'm going to want you to listen for. So, like again, like I said, it's going to be about an hour to get to the drop point. But as she gets out there, you're going to hear the pilot. We'll probably have the audio from the plane. She's going to say she's doing the cold pass. So that means we're getting to the drop point, but we're not going to actually drop the rocket. We're just going to make sure all systems are still go, make sure the ground antennas can still receive and track the telemetry. Then, while still in this racetrack pattern, we're going to, I'm just pausing here for a second to watch her.
So once the plane gets into the air, we're about an hour away from the drop, as they were saying. The reason for that is just that they need to actually go to the drop site, which is, you know, relatively far away. They also need to kind of check all their systems and make sure everything's okay. And basically, the plane's going to be flying in a basically like a U pattern. Oh, here we go. Look at that. Beautiful.
We are on our way. All right.
Wow.
Excellent. Awesome.
Happened so quickly.
Okay, so as I was saying, it's about an hour to get to the drop point. And when she's out in that drop point, we're going to want to listen for what we call terminal count. That means we're approximately 15 minutes away from dropping the rocket. That's where we're getting the stage 1 engine ready to start, going through a sequence of events to get that ready. And then you're going to hear a call from the crew for drop ready. And then drop ready mode lasts the maximum 90 seconds. So within those 90 seconds, we're going to drop the rocket and we'll hear release, release, release. So our plan is to have the audio from the aircraft on at that time so that we could hear that from the pilot.
So we should get some camera views of the drop, of the payload being dropped from the aircraft. And I think they might also have a view from the cockpit, although I'm not sure. We'll see. But again, here's the view of the fueling and what's going on inside of the vehicle.
Counter set LCC evaluation will begin once Cosmic Girl's over water.
So here's the view underneath the wing that I was talking about. So we should see it drop off of the wing when it gets to the drop point. But again, that's about an hour away now, just under an hour, because the plane will be flying to the drop site and performing its checks. It'll go through kind of like a racetrack pattern where it's flying in a circle, just to make sure everything's okay. And then when everything's perfect, they will execute the drop and get the rocket started and flying off to its destination. So it's a bit of a process, but just stick along with the stream, and you should see most of the key indicators of where they are in the mission.
Now, in case you're wondering what you're looking at there, we have a camera. We have a few cameras on the rocket. We have one camera that's facing back, like towards the back end of the rocket. But because we're attached to the wing right now, we're seeing what Keith described as the pylon that's holding the rocket to the wing, and then above at the top is the wing of the plane. We will on and on have the mission control audio on, so you might have heard them already talking about terminal count, although it'll be some time before we get there. But what a great shot. I'm happy to see that.
I hope they have more video than just this one. This is like looking down the rocket.
All right, so now that our aircraft's up in the air, it's probably a good time to tell you what exactly is going on or what she's doing right now. So I'm going to describe the flight path that she's taking. So as we mentioned earlier, everything was out at the Mojave Air and Spaceport. And so Cosmic Girl just took off from that runway out of Mojave Air and Spaceport. So she's going to fly a flight path that we've carefully coordinated with the FAA, just because we have a loaded rocket attached. And then she's going to go into what we call a racetrack pattern. So in that racetrack pattern, she's going to first start off by going to the cold pass. That's where I mentioned we pass the drop point and just check everything out without dropping the rocket. But then we'll go to that drop point again, and it's called the hot pass. And that's where we'll actually drop Launcher 1. And so that's what we're heading our way down to do right now. So super exciting. Before we do that last turn on the last pass, we'll go into terminal count, so you'll hear that, so listen for that, and then we'll go to drop ready. As soon as that rocket drops, there's a little bit of a delay before it ignites. Cosmic Girl will bank a quick right turn, and then she'll return to Mojave pretty much at the same path that she came out from. So let's now switch over and tell you a little bit about our pilots. Allison?
Absolutely. So we actually have two pilots aboard Cosmic Girl this evening. Our chief pilot is Eric Bippard. Eric has been flying since 1986. He's logged over 4,800 flight hours and over 1,000 flight test hours. If you want to play along at home, his call sign is Bip. And in the second seat, we have Matthew Stannard, who is the Royal Air Force test pilot on loan to us this evening. He's been flying since 2006, has over 3,000 flight hours and over 200 flight test hours. His title is Flight Lieutenant.
So these are pretty young pilots, I would say, and quite an honor to be able to have the opportunity to launch a rocket. There's not many people that can say that they've sent a rocket into orbit with the push of a button from a plane. So yeah, pretty cool. Definitely a job I would not mind having. Yeah. If you guys have any questions about what's going on in the launch process, or anything about Launcher 1, or why they're launching from the sky in an airplane instead of just from the ground, definitely feel free to ask and go ahead. I definitely want to address any of those questions that might come up. And here we're back on the what I like to call the engineering panel, where they're showing what's going on with the rocket in terms of its fueling and whatnot. I'm not really sure exactly what all of it means, though. I would have to look at it a bit more in depth. I wish they would show it for longer so we could try to figure it out. So just to give you an idea of the timeline right now, we're about 50 or so minutes away from the drop. They just showed the trajectory that the plane is going to take in order to get to the drop area. Because this is a rocket, of course.
My name is Bodhi, and I was just wondering, how high does the rocket ship go?
Well, that's a great question, Bodhi. Our Launcher 1 rockets fly to our planet's orbit. It can go up, 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 as high as 745 miles from where you are now.
I love these question and answers from Richard Branson. So just to clarify, Richard Branson is he's the no, he's not the CEO. I don't think he's the CEO. He's like the head of Virgin Orbit. So he's the main investor. He founded it. So he's where all the money is, of course. He's his main company is the Virgin Group. So he does things like Virgin Airlines. He also he's also the head of Virgin Galactic, which is the vehicle that actually takes tourists into space. So yeah, he's always a bit of an interesting character, and definitely one that has come into the space business a little bit more. But yeah, we're looking at the attachment. Well, we're not looking at it anymore, but that was the attachment point of the wing to the Launcher 1 vehicle. And basically, that's the pylon, and we're looking at it's a camera that's upper on the upper part of the vehicle that's looking down on that position. So we should get a view of the rocket as it gets dropped from that camera. I hope, because I think that's going to look really cool. And then, of course, we'll see the engine ignite and then see it hopefully take off on the way to space. I'm hoping they also show a camera from the actual plane itself, because sometimes it's really cool to see the rocket ignite and take off from the plane, especially if it's going to be in the dark, because then you really get a good contrast between, of course, the ambient and the engine exhaust of the rocket, which is always pretty cool. Yeah, but going back to why they're flying out to what seems to be the middle of nowhere, there's a reason for this, of course. We don't want to launch rockets where there are people nearby, and basically if something goes wrong with Launcher 1, that rocket essentially becomes a bomb, right? So if it falls on a populated area, like that's 30 tons of rocket and fuel, and yeah, that would create quite an explosion. So we need to make sure we do this drop in a place where if something were to go wrong and the rocket were to, go off course, or the rocket were to fail and, it falls out of the sky, it has to be safe. So they need to go away from the spaceport where they launch and away from people that are all populated there in Southern California, and go to a place where basically there's nobody, which is out in the middle of the ocean, which is where they're actually going to execute this launch. And I'm not really sure who this lady is. Are they showing it on screen as to who she is? Maybe she's the future pilot? Not sure. And also, just so that we don't misunderstand each other, Cosmic Girl is the name of the plane. So not the name of the rocket, it's the name of the plane. It's a plane that's dedicated to performing these launches with Launcher 1. Launcher 1 is the rocket, and Cosmic Girl is the plane. And of course, she's been specially designed in order to perform this type of launch. So she's been designed to have that rocket sitting underneath her wing. She's been designed to host the rocket all the way up to the flight altitude, and also to drop the rocket. So that pylon that you see on the left wing is basically the whole ground assist system, which is just in the air. One of the...
Next up, let's hear about some of the satellite payloads we'll be delivering tonight. First up, we have Gunsmoke L, which will produce 2 tactical space shuttle support vehicles, which will aid in all phases of joint force operations. Second, we have Modular ISR Satellite, a program intended to demonstrate responsive multi-mission CubeSat capabilities. The MIRSB CubeSats are the second in a series of missions to demonstrate various capabilities and mission effectiveness. And third, we have Slingshot 1, which is a program developed by the Aerospace Corporation to use a commercial 12U CubeSat as a demonstration platform for the use of new modular technologies to speed up system development, allowing for faster information. Now, we'll get back to some of the more payloads in a minute, but let's dive back into what inquiring minds want to know. Our next audience question is from Haley in Pacoima, California.
My name is Haley. My question is, when you send rovers up into space, how do you keep them from floating away forever?
Wonderful question. Well, Earth is a lot bigger than our satellites, so its gravity has a strong pull on them, and that is why they don't fly away forever. Since Earth spins, it pulls the satellites with it, and this allows them to stay above the same spot on Earth almost constantly.
So he was referring there to satellites that are placed into geostationary orbit. Basically, if you put them there, they spin at the same rate as the Earth, and it's a perfect balance point where you can do cool communication. Speaking a bit more about the engineering side, there's also engineering reasons for why we would want to have a rocket launching from the sky. So basically, rocket engines work on the principle of basically creating an explosion inside of the engine and then expanding those gases out into the environment to create thrust. And the more you can expand those gases after you've created that thrust inside of the combustion chamber, the more efficiency you'll have, and actually the more thrust you'll have. So one of the issues that we have when we're launching a rocket from the ground is that there's lots of atmosphere pushing in on the rocket exhaust at the end when it leaves the engine. So you can only expand the gases so much before you're doing it too much, and then you can actually damage your nozzle and cause really big problems. So it's much better if we actually launch in the air, because then we can kind of get rid of that problem, and we can expand our gases much further because there's less density higher up. And that allows us to get more thrust and higher efficiencies higher up in the atmosphere. Usually rockets are kind of optimized between their two stages. Like the first stage will kind of be optimized for surface level. So it has a engine bell on it that's not so big. And this is because basically if they expand those gases out too much, they're going to create problems. Whereas on the second stage, they have a really big nozzle because it's designed just to operate in space, basically. With Launcher 1, they can basically design a really nice nozzle for both stages, so they can kind of optimize how much payload they can get into orbit. And you see that with its payload capacity. It has a really high payload capacity for not being a carbon fiber design or anything. And the reason why they can do that is because it's an air-launched vehicle that's getting these higher efficiencies out of its engine higher up in the atmosphere. And that effect is actually stronger than the effect of having an extra couple hundred meters per second because you're being held on the aircraft while it's flying reasonably fast. If you think about the percentage of the speed that the aircraft actually has with respect to how fast the rocket has to go in order to get into orbit, that initial speed is almost insignificant.
Hey all, I'm back with a quick update from the MCC. We are currently reviewing all the data from Launcher 1, and the operators are judging it and assessing for stepping into terminal count. So that's going to be going on for a little while now while we proceed and approach that gate. So with that, let's take a look at some of the data the operators are reviewing by taking a look at our data GUI.
Beautiful.
So as you see,
an
The
explanation.
top, we do have the Launcher 1 vehicle. We have stage 1 on the left and stage 2 on the right. All the tanks are fully fueled and loaded up as we expect for being in flight. What you see next is our Newton 3 aux pump temperature. It's really important that we chill this down before flight to actually get it matching the liquid oxygen temperatures that are going to be flowing through it. So that all happens when we're in terminal count. So you're going to see that it is still sitting really high up at like Mojave temperatures. But once we start terminal count, it'll start being chilled down and getting into range. Next, you see the stage 1 propellant temperatures and pressures of the tanks. Those are reading as we expect for this part of the captive carry profile. Similarly, we have the interstage temperature reading within expectations, and the separation bottle for separating the two stages pressurized as we expect for when that kind of separates the two, pushes them apart. Stage 2 is reading within bounds as well for temperatures and pressures. And then the payload is still sitting in a very comfortable temperature to keep all of the sensitive and satellites set. Our bus voltages are reading within bounds as expected. And Cosmic Girl is up at that 30,000 feet flight level, cruising along. The pallets are pressurized or loaded still, and the pylon is properly pressurized, holding Launcher 1 attached as expected. So with that, we will take a quick break.
So that was a nice explanation of all the things that are happening on screen. So at least now we know what it's all for. Basically, you can see the propellants loading all on the top with the rocket diagram. The rest of it is basically indicating to you temperatures and pressure. He mentioned one thing, which is that they chill the Newton 3 engine. And like, okay, what does that mean and why do they do that? So basically, they need to cool down that engine down to the cryogenic temperatures. And the reason why they want to do that is because they're going to be using regenerative cooling in order to make sure that the nozzle doesn't, burn itself, like melt itself. So to do that, they have to feed in the RP1 into the engine bell in order to cool it down. And this, they're also going to be sending liquid oxygen into the combustion chamber through all of their equipment inside of that engine. And when you have all these cold fluids that are going through the engine, it can create a lot of stress. And if the engine is not properly cooled down, that can cause some problems with things like seals and connections. And if they have any flanges, that's always an issue. So they tend to want to do a cooling operation before they actually will launch a rocket. And they do that with basically all the rockets that are launched on the ground. But obviously, usually there's a bunch of ground support equipment to achieve that. Of course, if they're in the air, I'm not exactly sure how they're doing that. I think they might flow some nitrogen through it or something, but I'm not exactly sure. We'll have to keep an eye on it and see if we see anything. Anyways, that's the reason why they do it. They do it just as a precaution to make sure that they don't damage anything in the engine. Although theoretically, I'm sure it could actually go without doing a chill. It just would be risking damage to the engine. They also mentioned a bunch about the temperatures of the various different fluids and pieces of the rocket. That's basically the rest of the panel. And it's just telling us, what temperatures and pressures the tanks and the interstage and the payload are operating at. So if we see something weird, we'll definitely see it on that panel if they show it to us. Hopefully they'll be happy to show it more often. If you guys have any questions about the mission in general, about Launcher 1, about Cosmic Girl, about the mission that's being performed, or anything to do with the engineering of the rocket, be sure to let me know.
My name is Sadie. And my name's Tura. And we want to know, how fast does the rocket ship go?
Hello,
Very
Sadie
good question.
Laura. The rocket goes very, very, very fast indeed. Its maximum speed is 17,500 miles per hour, or 28,163 kilometers per hour. It must go this fast, otherwise it gets pulled back to Earth by gravity.
So of course, that is the speed at which you have to be going in order to get into orbit, which is why it's the top speed of the rocket. Although it could go a bit faster, if you reduce the payload mass, it can actually go a little bit faster and get to higher speeds in order to get into like a sun-synchronous orbit, which is a little bit more energy. And if they reduce the payload mass to like only a couple kilograms, I'm sure they could go even faster. But that's what it's rated for how they sell the rocket anyway. But maybe a bit misleading, him saying that's the top speed. So yeah, if you guys have any questions about anything to do with the rocket or the vehicle or the system, please let me know. I'm a space engineer, so this is kind of what I study. I'm in my final semester, just finishing up my master's thesis. So I've definitely lived in this aerospace and rocket world for a while, and I can definitely answer questions that are coming up. Just to give you an idea about also what I'm doing, I'm part of a student group called ASTRA, which is basically focusing on building a rocket which will go to space. it's not going to be going into orbit like Launcher 1 here, but it will be going into space and coming back down. And it's trying to be the first European rocket that's built by students to do this. So we have also a bunch of stuff that we're doing in order to make this rocket launch possible. And you can kind of see what's going on with our group if you go check out our channel. We have a bunch of videos up about our rockets and the things that we're testing, and yeah, hopefully leading up pretty soon here to some hot fire testing campaigns and potentially a launch by the end of the year. So we're really looking forward to that. The rocket that we are building is called Transcendence, just so you know. We got some weird stuff happening here with the interstage temperatures. I'm not really sure what they're trying to show there. But they were kind of switching back and forth. But everything seems to be okay though. Yeah, as I was saying about the Astra rocket. So we are building a rocket called Transcendence, and that rocket is going to be what goes to the Kármán line.
So as we're waiting for Cosmic Curl to get to that drop point, we want to tell you a little bit more about the payload. So another payload on our vehicle today is called the Compact Solar Total Irradiance Monitor, CSTIM. So
this one's not military.
It's a 6U CubeSat. It has specialized sensors and instrumentations to measure the sun's energy entering the Earth's atmosphere. So given that the sun is our predominant energy source, I could see how we can get a lot of useful data from this. So a very interesting one there too. Another one is GPX2. So this is a technology demonstration of differential GPS. So differential GPS uses both GPS satellites and ground station satellites on the ground. And it's set up to like significantly increase the accuracy of the GPS. I did wanted to add a little bit too, and you might have heard a little bit when Lieutenant Colonel was talking, but this mission is also known as STP-S28A, STB being the Space Test Program. And it was awarded to Virgin Orbit via a subsidiary, Virgin Orbit National Systems. They actually won a contract with the U.S. Space Force on their Rocket System Launch Program, or RSLP, which is part of the OSP-4 contract. So I just wanted to add that. I know the Lieutenant Colonel had mentioned it earlier, but I wanted to mention it again.
Thanks, Alex.
These military guys and all their acronyms, my goodness. Yeah, basically the first payload they talked about, MISRB, that one is not a military payload. It's just a payload that's being built by the University of Colorado. And it's going to be monitoring radiation levels around the Earth and creating a map. And that's going to help with things to do with climate modeling and things like this. The other one is purely a military payload, which is going to be basically trying to enhance the resolution of GPS. So, yeah. I don't think that will be for the general use, though. It's probably going to be mostly for their, things like their missile systems and other tactical reasons for having increased resolution of a GPS system. But yeah, all of this is kind of part of their space test program, which is a whole bunch of launches that are being awarded towards all kinds of different launch vehicles. And it's basically missions which are testing out new technologies where they're going to use in space and enhance their tactical capabilities. So there's always a lot of money involved with military related payloads. So that's good for launch vehicles. Of course, there are some political implications for dealing with military payloads, but that's part of the industry at this point. I'd be very hard to be a launch vehicle that deals strictly with non-military payloads, because I would say, like, at least certainly in America, over half of the launches that are available in the commercial market are military payloads. So that's just kind of comes with part of the game. So, just to talk a little bit more about or I should mention before we get into other stuff, that if you guys want to know more about the specifics of what's going to happen soon and the vehicle and things like that, I did talk about them earlier in the stream, so you can always go back and check out those various details to get a more in-depth look into what's happening. We also have this nice panel that keeps showing us that shows us the status of the vehicle. We can see that she's fully loaded, and we can see the different temperatures of the stages and the pressure that the stages are at. And this is telling us basically that she's configured for flight and ready to go. If we see something weird, we'll see it on this panel if they're up for showing it. So just keep that in mind. We're about 35 minutes away from the drop, which is when basically the rocket will ignite and take it and fly it off into space. Of course, this is an air-launched vehicle, so it's flying from Cosmic Girl, which is the Boeing 747 that's carrying the rocket, and it's basically mounted underneath her wing, and 35 minutes from now it's going to drop the rocket, and the rocket will ignite its engine, and that'll be what carries it off to space. So it doesn't launch from the ground, it launches from the air. So definitely an interesting configuration for a rocket. But while we wait, I would also like to talk a little bit more about ASTRA, which is the student group that I'm a part of, and it's a student group that's based in Bremen, and we are trying to build a rocket which goes to space. It won't go into orbit like Launcher 1, but instead it's going to be going up to the Kármán line, touching space, and hopefully becoming the first European student group to get that high. And just to give you a little bit of an idea of what our rocket is kind of looking like, you can see it here. It's looking like a rocket. It's going to be basically not too big. It's going to have a mass of 265 kilograms. It'll be about 6.5 meters high. So if you think about yourself, it's going to be about 3 times taller than a person. It has these fins on the bottom, which are going to passively stabilize it on the way into space. And it has a big engine, which is generating 24 kilonewtons, which is quite a lot. It's getting close to some of the thrusts that some of these commercial rockets are producing, but it only burns for about 15 seconds, so it doesn't have the energy to go all the way to orbit, just to get itself into space. And that's going to be the rocket that we're trying to build in order to go to space, and that's kind of the purpose of this channel, is to create awareness about our Transcendence rocket program. But we like to stream these launches because it gives us an insight into basically the commercial space industry, and learning more about other rockets and how they do things and how they solve their problems is always interesting. And it's always nice to also know about the diversity of rockets that are out there, because there are so many right now. All kinds of different systems with different weird intricacies that make them competitive in different ways. And I think it's good to spread awareness about that, about how many different ways that there is to go to space, and different ideas that are being tried right now by engineers, because it's a really cool industry to get into right now. So if you're young and you're interested in like anything to do with aerospace or space, like there's a huge market for your services in the future. So study hard and know that there is definitely cool work that is out there. And one more thing I should say is that if you are liking the attire that I'm wearing right now, this is part of our merch store that we just launched. So if you want to get like some cool Astra gear, just check out our website where you can access our merch store. I'll put it in the description after I finish the stream. And you can go check out what's going on, and we have a bunch of other products in there, like t-shirts and water bottles and hats and sweaters. So yeah, if you like it, this is one way you can help support the group.
Welcome back. We had some cool shots there of the pylon and the rocket again, and we very quickly saw a little animation of where our aircraft currently is, so we should have that back up again. I want to tell you a little bit more about a couple more of our payloads that we have tonight, or our satellites. So another one is called Nachos 2. You would have heard the Lieutenant Colonel mention that one. So Nachos 2 is going to measure dilute gases in the Earth's atmosphere to kind of track things such as volcanoes and climate change. So as the name implies, it's the second of a series. So there's a Nachos 1 and then there's a Nachos 2. And so part of what they're also going to do is see how these two satellites can work together to collect this kind of data. Another satellite that we have going up into orbit today is called Recurve with our Air Force Research Lab. So it will demonstrate adaptive radio frequency capability from low Earth orbit platform. So basically using RF antennas to talk to the satellite from the ground. So some good tests and experiment that we can do there. Now our current flight today is actually very similar to our last flight, Flight 4, that we called Above the Clouds. It was also a 500 by 500 kilometer orbit to a 45-degree inclination, as I had mentioned earlier. So let's go ahead and check out this video with a little bit recap of that flight.
So just to be clear, the 45-degree inclination is referring to the inclination of the orbit.
The morning of is an interesting thing. You're very excited. There's a lot of anticipation. There's a big element of trust and reliance upon the people who've built the rocket.
Ground on control, S1 LOX load is complete.
And this was the first successful launch of Launcher 1.
It's not uncharted territory anymore. We know what we're doing. We've done this before. We're getting confident. We feel good. Your imagination kind of stops. You go into muscle memory, and then you deliver.
LD comes check the plane, Honeywell.
Good morning. You ready to launch a rocket today?
It's crazy to see the empty 747. You're still used to seeing seats in there.
Update from Chase. They're in the racetrack. Clouds are from 30,000 feet up to 34,000 feet, all through the racetrack. It's a solid cloud deck.
Orbit base, LE1, are you going for takeoff? Orbit base, LE1, Cosmic Girls Airborne.
Copy, airborne. Orbit base, Cosmic Girls Airborne. We are in clouds at 17,000 with a hold G2 to 20,000. Be aware there are multiple layers of clouds out here. We're in the clear at the moment. I expect to go back into it in the racetrack.
5, 4, 3, 2, 1. Terminal count initiated.
Cosmic Girl, accelerate.
Orbit base, LE2, rocket is on internal power.
Vehicles in drop ready mode.
Copy, drop ready.
Release, release, release.
It's also crazy that they can basically have the entire launch control like inside the rocket, or sorry, inside the plane.
Light.
You know, as I'm doing this right bank, I look out my window and I see this bright plume with this rocket, you know, just shooting into space, and it's a pretty awesome experience.
So you'll see basically the plane do a right bank as it finishes dropping the payload. It also kind of goes into a little bit of a climb, which can be quite interesting.
It was fantastic today, though, to show the capability that we can get through that inclement weather, get the rocket to somewhere nice to be able to launch it, which was, showing the capability that the aeroplane's got, which was great.
And then some nice onboard footage. Wow. Wow, this is some really nice onboard footage. So basically, yeah, the plane will actually go into a little bit of a climb just before it launches the rocket, and that's just to get its orientation into a nice place where the rocket is going to be pointing up. Of course, it's only at 10 kilometers, and because you're launching from a plane, the drop has the rocket kind of coming in horizontal. But you still need to clear the atmosphere before you can get into orbit, right? So that's going to be above 100 kilometers. So the rocket needs to do quite a lot of climbing. So that's just to help it orient itself nose up so that it can execute that climb over the next couple of minutes. And when Cosmic Girl does that brief altitude lift just before it's going to drop the payload, if you have a camera on that, it's usually quite spectacular, just because of the way the air is flowing around the vehicle and everything. If you have the sunlight in the right place, it can be quite nice. Unfortunately, today it's going to be in the dark, so you won't necessarily see that, but we will see the bright ignition of the engine, which will be quite brilliant. And you saw there just on the screen, they were still flying out to the racetrack area where they're going to be flying basically a loop before they launch or drop the the Launcher 1 rocket. And they're almost there. So I think they're just about 8 minutes away from the racetrack. So we're getting close to the point where we're going to be ready to fly the rocket. The drop of the rocket is, of course, scheduled for 24 minutes from now. So keep that in mind. And we're once again here with the animation of the technical details of the rocket. They're not super technical. It's just basically the fueling levels and the temperatures of the various propellants and the parts of the rocket. So one thing to note is that the oxidizer is always being held at a much cooler temperature than the fuel, and that's just because it's running on liquid oxygen, which of course stores its fuel at minus 180 degrees Celsius. So
back. I do have some updates from the MCC and Cosmic Girl. Cosmic Girl is reporting that everything is nominal as expected, and the MCC has worked through its terminal count checks and verifications to make sure that we are good to step into that operation. That should be coming up at about 17 minutes to drop. That will step into terminal count. And then additionally, we have gotten verification that we are receiving telemetry from our Long Beach headquarters, which we transmit to as we get closer to the drop point. So that's all going forward nominally and as expected. So now let's take a chance to look at the rocket flight profile that it's going to fly after Cosmic Girl drops it. So Cosmic Girl will drop it at 35,000 feet. We'll then, 5 seconds later, ignite the Newton 3.1 engine. That'll power us for 3 minutes to get us to our main engine cutoff point once all the propellants are gone. We'll then do stage separation and let Newton 4 take over and start powering the remainder of the vehicle for the next 6 minutes until we get to our second engine cutoff point, which we will then be at 170 kilometers up above in altitude. We'll also now be in a transfer orbit that is going to let us proceed around the world and gain altitude on the way. As we do that, we're going to rise up to our 500-kilometer target for deploying the payloads. We're not done quite yet, though, because we have to do a second burn of our Newton 4 engine to circularize at that orbit. So we raise up to a 500 by 500 kilometer orbit. We'll then move forward and deploy the payloads, and after that we'll then be done with our mission and we'll have mission success. So that is the profile, and with that I can hand it back to Allison.
So just speaking to that profile a little bit, basically the booster is going to be doing most of the work to get the rocket out of the atmosphere, and the second stage is going to be doing most of the work to get us to the velocity that we need in order to circularize, in order to have a circular orbit around the Earth. So those are kind of the two functions, the main functions of those two pieces of equipment.
I believe that if you're on the beach in the Southern California area, you may be able to see us flying out in the distance, low on the horizon.
So if you see an unexpected mark in the sky, that just might be Virgin orbit tonight. But make a wish anyway.
If you're out on the beach at 12 o'clock at night.
We're getting really close to drop right now, so we'll
it's
be
quite
back
a time
in
to
a
be
few
at the
moments.
beach. Yeah, so just to reiterate the location of the launch, they're launching, so they've lifted off from the spaceport out in the desert in California, and they're flying over to just west of Los Angeles. So basically, if you're out on the west coast there, you might be able to see the rocket. Potentially. If you look really closely, it'll be kind of low on the horizon because they're kind of a ways out there. And yeah, you might see like the bright flare up of the engine, and maybe some of the bigger engine exhaust that comes off the rocket when it gets higher up into the atmosphere. just because it'll be higher up and it'll be easier to see. So if you are on the West Coast, look out for that. Also, if you have any questions about the rocket or the plane or the system, do please let me know. I can answer some of these questions for you, hopefully. I'm a space engineer, so there are some things that I may know to be able to help you with some questions. Yeah, it's really a cool system, and I'm excited to see what's going to happen soon here. We're only 20 minutes away now, just under 20 minutes, 19 minutes away from the launch of this rocket. It's going to, again, drop from Cosmic Girl in order to get itself into that into the orbit that it wants to go into. It's an air-launched vehicle, so that's why it's being dropped from Cosmic Girl, which is basically a retrofitted 747, which is designed to carry this rocket. And here you can see, again, the screen of all the technical details. If you have any questions about this, also, do feel free to ask. They did do an explanation about 15 or 20 minutes ago about what all of the different pieces were indicating. For the most part, the top part is dealing with the fueling levels. That's the animations that you see inside the rocket. Of course, they fuel this rocket on the ground, so that part should all be fine as long as there's not a leak or something. The reason why they have to fuel on the ground is because it's an air-launched rocket, so it doesn't have like constant ground support to be able to constantly be filling it up as it flies to its destination. But you can also see here the temperatures of the various pieces of equipment. One thing that you will notice is leading up to the launch, like when we get closer to the actual T-0, you're going to see that on the Newton 3 part of the screen, you're going to see the temperature of that rocket engine bell decrease. And the reason why they're doing that is because they're trying to chill the engine before they start it up. You have to do this because if you don't, you can stress the equipment. And when the liquid oxygen starts flowing through it, basically that can cause issues with seals and flanges and stuff like that. So it's important that they do this engine chill procedure. And it's a good indication that things are nominal and on track for success. Everything else should stay stable, though. Nothing else should be changing too big.
Everybody. Now, you may be wondering why we've named our missions Straight Up. Well, that's because here at Virgin, we name each of our missions after a hit album from Virgin Records. Our first commercial launch was Tubular Bells, named after Mike Oldfield's 1973 debut album, which was also the very first release on Virgin Records. And then our second commercial release was Above the Clouds, which was named after the 1998 Gangstar album. Now this time we are paying homage to American singer Paula Abdul and her breakthrough hit, Straight Up, from her album Forever Your Girl. Yes, all right. Hey, baby. Okay, all right. I promise no karaoke in the studio, but after the live stream, it's go time. Now, last week was the 34th year anniversary of the album's release. Paula, we are huge fans over here at Virgin Orbit. Thank you so much for inspiring this mission. And now for a surprise video from the legend herself.
Oh, wow. Okay.
I cannot believe that the day is finally here.
This is the lady that was in the cockpit before.
That Richard Branson wanted to name his next orbit shuttle Straight Up.
Wow.
And here I am in the Mojave Desert. I got to see the Straight Up shuttle that's going to be dropped tomorrow night. It's the first ever evening flight, and it's going to be, if you're by the ocean, between 10:45 to 11:45, you will probably see it. I can't believe it's called Straight Up, Straight Up, Straight Up. Oh my God, I'm freaking right now, and I'm here just seeing all these geniuses do what they do best, and my hat goes off to them. It's fascinating what I've learned so far, and let's go take a look. Let's go take a look at the Straight Up orbit shuttle.
This is so cool. Another way you can get onto to see Cosmic Girl is just make cool music, and then Richard Branson might name the rocket after you. So yeah, she was the one that was in the pictures of the cockpit earlier on in the stream, and we were confused as to who that was. But yeah, really awesome that Richard Branson, he always does these cool public things where he tries to involve people in the space industry. Yeah, that's the one cool thing about Richard Branson. He knows how to do the public outreach, you know. Yeah, his company was also one of the first ones that I was excited about as a kid. Oh, it looks like we've gone into the racetrack pattern here. This is a good sign. So you see how it started to do that curve, and it's going to be coming back around. Basically, it's going to fly in this loop here, and then when it comes back around on that loop, it's going to have its opportunity to launch. So we are close here. We are getting close. Only 13 minutes away. So it's going to get back around that loop and back to the starting point, where I think it's going to do the drop on that second loop. So the red path here is showing the path that the rocket will take, and the yellow one is the path the plane will take. Maybe it might be the other way around. No, sorry, I think I'm crazy. I think the red one is the path the plane will take, because it's going to bank. The rocket should go straight. If the rocket's banking, that's not good, right? To those particular activities, the engine chill, checking that the telemetry is working, and that they're getting good ranging. And they will probably be doing that both for the rocket and for the Cosmic Girl. They also want to make sure that Cosmic Girl's in the right place exactly, because in order to get into the orbit they want to go to, of course they want the plane to be starting from the right spot. So they'll also be making sure that that's all.
Hi Owen, how do you keep communication with the rocket when it's moving every 20 feet?
Owen, that's a brilliant question. The rocket moves very fast, and the Earth itself is moving fast as it spins too. And we have satellites here on the ground all over the world, so that our communications with the rocket are always covered.
So that's actually a reasonable explanation. Basically, the way they communicate is by going through satellites that are in space already. So they have these networks that are already set up.
Okay, so
but they also communicate with ground stations.
In the last few minutes. So you can kind of tell from that graphic that it's in that racetrack pattern. It already passed the cold pass of the drop point, and as you heard, we're in terminal count with about 9 minutes left to the drop time. So when we drop, a lot of things are going to happen really fast. So I want to kind of describe it now, because we'll have the mission control audio on so you can listen, and then we'll recap after, but I want you to know what to listen for. So obviously you're going to hear release, release, release. And so that's when the rocket is dropped. And then the propellant selling thrusters, or PSTs, are going to ignite. So you'll probably hear PST2 ignition. And then you're going to hear main engine start. And then you should hear a call out for max alpha. That is the most difficult part of the trajectory of our flight to control. So we definitely want to hear that we've gotten through max Q alpha. And then the next thing that we're going to hear is, well, that was max alpha, sorry. The next thing we're going to have to hear is max Q alpha. That is the most stressing part of the trajectory. That's where most of the forces are on the rocket. So we want to hear, hey, we've gotten through max Q alpha. Then we're really getting up there, and we're going to eventually get to down throttle. So listen for a call out for down throttle. That's when our sense acceleration is 5 Gs, and we didn't want our satellites to sense more than that. So then we down throttle our thrust to a lower state point level. And then very quickly after that is going to be main engine cutoff, and we'll be coasting for a little bit, and we'll separate stage 1. So hopefully we'll be able to see our aft cam on the rocket and see that really bright plume that Keith described, and
Beautiful.
See the separation event itself.
We're going to see the aft cam.
Pretty soon we'll turn up that audio on that mission control, and we'll listen in. So next we want to listen for drop ready, and then we're going to want to listen for release, release, release. So we'll be right back with that. Thank you.
So just to clarify, because I know usually you hear the max Q call out in rocket launches that go from the ground, and that has to do with the maximum aerodynamic pressure that is experienced by the vehicle. So basically the most friction that's being caused by the atmosphere acting on the rocket. And of course that goes up at the start because the rocket's going faster and faster and faster, but it's also decreasing as it flies higher because there's less atmospheric pressure. So there's a sweet spot where it's exactly the most, and it's, you know, usually somewhere around 10 kilometers. When the vehicle's going just over Mach 1, you'll get that max dynamic pressure. But here they're talking about a max alpha. So what does that mean? Maybe we have something here. But max alpha is basically when, because the rocket is launching horizontally and it needs to gain altitude.
Base tracking, no issues.
Okay, that's good.
Copy, tracking, no issues.
So this means that they have good communication right now. So they don't have any issues there. But what I was saying about the
Order base, Cosmic Girls, rolling out, inbound turn, hot pass.
Base comp base, inbound hot pass.
Okay, so they're just going to be starting the hot pass now. They're just turning. And once they turn around fully through this loop, they're going to be on the final course, where they're going to be just at the end of that line. They're going to be doing the hot drop, which is the drop of the rocket and the ignition, of course. And just to clarify what the maximum alpha is, basically because they're launching from horizontal and they need to get altitude, they need to turn the rocket a little bit, and that creates a stress on the vehicle because it's in a higher pitch than the movement that it has across the sky, and it creates this basically crosswind that's hitting the vehicle. And there's a maximum point of that, and that can create a lot of stress on the vehicle as well. So they also will tell us when that's happening, and that'll be relatively early in the flight. So we're going to be trying to listen out for the engine chill, because they'll be doing that now.
The S1 tanks are at expected pressures.
Copy, S1 tanks at expected pressures.
Okay, so pressures are looking good. We're going to see Cosmic Girl coming out of this turn momentarily, and then we should be just minutes away from launch. We have just 4 minutes left on the clock right now before they will execute that drop. And you can already see that they've started the engine chilling, because that engine chill bar has gotten shorter. They're going to be going all the way back to that white line, and that's the just under the Newton 3 part of the GUI. We want to see that gray bar go below the white line. That means that the engine is chilled and ready for flight. And they do that just before they launch, just so that they can protect the integrity of the rocket engine, so the cold liquid oxygen that's at a minus 180 degrees Celsius doesn't cause any issues. If you're just joining the stream, we are minutes away from launch, just 3.5 minutes from the drop of the... Yeah, 3 minutes away from the drop of the rocket from launcher, from Cosmic Girl. And if you're looking for some more technical details about what is going on with this whole launch system, be sure to take the stream back a little bit, because we went into detail about all of the different steps that are happening here. And you can see we're on the final pass. So the plane is now coming back around, and
Battery power is enabled.
And the engine chill is also almost complete. You can see it just on the Newton 3
Forward
part.
base, two vehicles on internal power.
Base comp base on internal power.
When they say it's on internal power, that just means that the rocket is no longer connected to the power of the plane, and now it's ready for drop. And you see that the engine chill is now just about complete.
Orbit base, LE2, aircraft S-band and AFSS confirmed go.
Base comp base confirmed go.
Looks like we're ready for launch, guys. All systems are go. Just 2 minutes away now.
Like I mentioned earlier, we were turning up the audio on mission control, but actually that's the audio from the aircraft itself. So you've been hearing the voices of Sarah Barnes and Dale Alexander. And I've heard the pilot.
Engine chill nominal.
So let's listen in.
So the engine chill was just confirmed to be successful. And we are now just over a minute and a half away from the dropping of Launcher 1 from Cosmic Girl. Cosmic Girl is the 747 that is carrying Launcher 1 on this path to launch from the sky. And if you want to know more about that sky launch system, do be sure to take the stream back a little bit, because we went into detail about each of the systems that are involved here. Hoping they switch to the camera that's on the pylon where they're going to drop it. They do have a camera that's on the upper stage of, on
every
the...
time you heard nominal, that's good. That's as expected, which is awesome.
We do have a camera that's on the rocket that looks down at the booster, so we should get some good camera views from that.
OV, radio head on control room. S-band lock acquired in Long Beach.
Copy, S-band lock acquired in Long Beach.
Hey, good news there. So our antenna on our Long Beach antenna has reacquired lock. We knew that there was a bit of a blockage from some hills in the area, so it's nice to get that back.
Okay, 15 seconds to the drop here. And this is the camera that's looking down at the booster.
Is what allows us to get this video, for example, the one right here showing them.
Or base vehicle is in drop ready mode.
Oh, excellent. Drop ready mode. So we're dropping in like 90 seconds max. Let's listen in.
Once they move into the drop ready, they have to drop in 90 seconds, otherwise they will recycle.
Guard warning. Release.
Here we go.
Yes.
Confirmed release.
Base copies.
It's been released. And the rocket has ignited.
Base copies. Good
PST's ignited.
Beautiful.
Startup complete.
She's saying it. We sent it. Or Launcher 1's going straight up to space.
Base copies. Well done.
Video's a bit choppy,
Incredible
but
job, Elise.
she's working.
Awesome. In the studio, can we switch over to MCC audio?
Everything seems to be going relatively nominally here. You can see that the engine is working to stabilize the rocket by using that gimbaling. That's why the plume is kind of moving around a little bit.
Stage 1 burn nominal.
So this is now going to burn for about 3 minutes.
Max Q alpha achieved.
And that was the point in which we had the highest tilt of the rocket compared to the ambient movement of the atmosphere. That can always be a bit of a structural concern. This is special
All
to...
right, so we kind of switched between the plane audio and then mission control, but I heard the call out for Max Q Alpha. So that is a huge milestone during stage 1. I also heard a call out for propulsion being nominal. So that is fantastic, and what I can see on the video looks great.
Stage 1 PU nominal, halfway through burn.
Okay, so I just heard halfway through burn and still continuing nominal, so that's all as expected. This is fantastic.
So everything appears to be going nominally.
Stage 1 burn nominal.
We are looking forward to the separation of the booster from the second stage in just over 1 minute here.
So we're waiting to hear next is going to be down throttle.
Stage 1 trajectory nominal.
And main engine cutoff. And now that was a call out from our guidance, navigation, and control engineer that GNC was nominal as well. So nominal propulsion, nominal guidance, navigation, and control.
The reason why they do do a down throttle of the engine near the end of the burn is because they don't want to actually crush their payloads, because they're actually capable of producing more G-force than they can withstand.
Because that will ignite as soon as, well, closely after stage 1 burns out. If you recall, I said stage 1 will burn for approximately 3 minutes, and we're currently on a 2-minute and 30-second count.
And also, just
Stage
apologies.
1 throttle down commanded.
Okay, so there was down throttle.
S-band lock for Baja TM, data confirmed.
You can see the altitude of the vehicle also on the left-hand side.
Sky,
3 shutdown confirmed.
Engine shutdown
Stage
confirmed.
7 brake wire is broken.
All
Okay,
right.
Stage 1 has separated.
Newton
Because
4
it's-
startup complete.
Okay, so that was a call out that Newton 4, stage 2 has ignited.
So now we're looking at the Newton 4 engine.
Fantastic.
Switch to S-band from Baja.
So now what you just heard is our antenna that's in Baja, California, is now what's picking up the telemetry data. Long Beach also can still see it, but Baja is going to be the one that sees it longer, so they switched over to it.
Fairing brake wire is broken.
Okay, I was about to say we're listening for fairings.
So you just saw the fairings fly off there?
So
The
as
reason-
expected.
The reason why they let go of those fairings is because they're out of the atmosphere now, so they don't need them. So they don't want to carry that dead weight all the way with them into orbit.
Right
Not
now this
sure
is
what the
camera
camera is.
forward. You could see it at the top. Now, when we get to the other side of the world, we would have sunlight, but because it's night, we don't have any lights up on the front, and we don't have the plume from the stage 2. The cameras will switch back and forth between forward and aft. So back to the aft, showing the stage 2 plume.
Okay, so this rocket is going to burn for 6 minutes or so. So that's another 5 minutes from now. That's how long it's going to take for it to get it all the way into a stable orbit.
It's just very dark right now, so we won't see much on that one until later.
Yeah, when they switch to the top camera, it's just going to kind of be black,
Stage 2
just because they're
trajectory
launching in the dark.
Excellent. Stage 2 trajectory as expected, nominal. So this burn, so the timer there is from drop. So this burn ends approximately 6 minutes after drop, which would officially put us in our transfer orbit. You'll hear a call out for second engine cutoff, number 1.
So we're going to have that second engine cut off
Stage 2 burn nominal.
in about 4 minutes. And that will put us into a elliptical orbit, which will take us from the 170 kilometers or so all the way up to the 500 kilometers at apogee. And unfortunately, the altitude readings are in
yeah, take a look on
US
the
units.
left-hand side there. We have rocket
But
with speed. We've got altitude going up, up, and up.
if you want to convert from feet to meters,
569,000 feet.
just divide by 3. That's usually the good rule of thumb. So 569,000 feet
Stage 2
is about 160 or so kilometers.
Burn.
Also, the target velocity being the 28,000 kilometers per hour, but of course they're showing speed in miles per hour, so it's actually about 17.5
So when it gets
thousand
to
miles per hour.
second engine cutoff number 1 right now, we're going to be in an orbit that is 177 kilometers by 510 kilometers. It's our transfer orbit. And then we're going to coast for about 45 minutes to get to that
Stage 2
higher
burn
altitude.
nominal, 2 minutes until SECO.
All right, I kind of talked over it a little bit, but continue to be nominal. And they called out, I believe, 2 minutes until second engine cutoff. Or SECO.
All right, we're
Look,
getting
I'm
to the
so
end
excited
here.
right now that I can't even believe it's 12 a.m. I don't even feel a peep of being tired.
12 a.m. for them. For me, it's the morning. I'm streaming this from Germany, so.
And our speed is increasing quite a bit.
Yes. Oh, yeah.
So it's good to note that
altitude.
typically, like when you're going through these burns, because of the rocket equation, most of your speed is actually added in the last minute, because that's when the vehicle is the lightest and that's when you get the most kick out of your rocket. So if you're looking at the velocity indicator, which is just above the altitude one, it's going to be rising quite quickly in the end phases of this burn. So look for it getting up to 17.5 thousand miles per hour, which is roughly equivalent to 28,000 kilometers per hour, which is the target velocity that we're going to need in order to get into the orbit they want to move into today. They're also going to be getting up to an altitude of roughly 600,000 feet.
Seconds to go.
Okay, I'm just going to listen in.
AFSS mission rule satisfied.
Hotline to LD on control.
Newton 4 shutdown confirmed.
All right.
Excellent.
Hotline to LD on control.
Go ahead.
Permission to release the airspace since we've satisfied all AFSS requirements.
Permission granted.
Copy, thank you.
Excellent. So what we just heard was that second engine successfully shut down. That means the guidance navigation control determined that it had reached the transfer orbit and shut down the engine. We will very quickly right now go out of view.
These are some nice graphs here. You can see basically the second stage of the vehicle here in the middle, but you can also see the altitude and position data that's in these graphs on the top part of the page. So particularly on the left-hand side, oh, they just switched. Why are they switching? Okay, so the rocket's going to be following this the red path here.
Okay, so very exciting. So we've officially reached
or the white path,
our transfer orbit. I'll see if I can get some details about the orbit.
They keep switching where everything is on the screen here. But anyways, on the left-hand side of the graph here,
so I think with that, we'll just
you can see the
confirm
altitude.
some of the data, and we'll come right back.
Everything seems to be progressing nominally. So they just got into that transfer orbit. So that's going to be an orbit that's going to take them from their altitude of about 177 kilometers up to the 500 kilometers that they're trying to target today. And you'll see its orbit raising on the left-hand part of the graph there, because it's going to basically be going upwards on that elliptical path. And it's not like the engine doesn't have to be on for it to do that, because basically they're using orbital dynamics to get them up to that apogee where they're going to release the satellites. So because they've put in all the energy with the burn here at the start, they've kind of pushed themselves onto that elliptical orbit, and now the rocket just kind of free coasts up to the top, kind of like how when you throw a ball, it continues to go up even though you're not pushing it anymore. It's just free floating up to that point. And that's kind of what's happened with the rocket here, is it's just going to free float up to the 500 kilometers. And then they're going to do a circularization burn. So they're going to light that rocket for like 1 or 2 seconds. And that's going to bring the periapsis also up to 500 kilometers. And then it'll be on a circular orbit. But if you just want to kind of follow on where we are in terms of the launch sequence, so to say, we're going to be, if you look on the left-hand part of the screen there, you'll see the altitude. And yeah, it takes about 90 minutes for a satellite to orbit the Earth. So we're going to be doing half an orbit here. And that means that we're about 45 minutes away from when they're going to light up that engine again and then perform that circularization maneuver.
Next expected target acquisition at part of East Docket.
You also heard at the end of the callouts there that they had released the airspace to back to the commercial sector. So basically they have to block out the airspace around Cosmic Girl and Launcher 1 and the whole area where Launcher 1 is kind of flying over, because if there were anything to go wrong, you don't want to have a chance that that rocket will crash into another flying vehicle like a plane or something, or potentially hit like a boat down in the water somewhere. So they will basically put a restriction on the airspace around that launch and also on the ground. or in this case, on the water, where people are not allowed to be. So at the end, you saw they had a call out saying, "Oh yeah, we allow you to release the launch airspace," and they got confirmation of that. If you want to know more about like launch locations and delays and things like this, and why certain launch locations are better than others, and why rocket launches sometimes get delayed, you can go check out some of our videos that we've done on this. We have some videos about that kind of go more into detail about the specifics of what makes one launch location better than another, and also about why launching from a plane actually might be one of the best ways to launch a rocket, because it has some really unique advantages that we're seeing with Launcher 1, where it allows it to compete really well with the commercial sector.
Thank you so much, Alex, for that play-by-play. Now, here at Virgin Orbit, our first mantra is do no harm, which is why our recycled and repurposed 747 Cosmic Girl prevents the need to build out new launch pads, and instead we can launch from any runway at any time. And because we launch in the air, we emit 90% less carbon onto the ground area as compared to ground launches. And the small satellites we launch help monitor things like climate change and study the Earth, helping to further our mission to open space for good. So to put things in perspective, Virgin Orbit's total impact in 1 year is still less than 1 hour's worth of flights out of LAX. That really gives you a perspective on that. Next up, Virgin Orbit branches into new territory as we prepare for our first international launch. We'll be launching out of Cornwall, and this will be the first ever orbital launch out of the United Kingdom. So it's going to be very exciting. We'll be back with you in just a minute.
So exciting that they're planning to launch out of Cornwall in the UK, because ASTRA, the student group that I'm a part of, is also planning to do some launching out of the UK in the future. So maybe we'll see each other. Unfortunately, we don't. We'll of course go from a launch pad, not from a runway. So it's going to be a little bit different. But like the announcer was saying there are some really awesome advantages to launching from the sky, and maybe we can just quickly go over a couple of them. One of them that she mentioned was that basically they can launch anywhere in the world, right? They're not restricted to a location. And the reason why that's important is because if you are launching from a specific location on Earth, it limits the inclinations of the orbits that you can go into. So that's the tilt of the orbit as it flies around the Earth. If you launch from a more northern latitude, like where most of Europe and North America is, you are kind of limited because you can only go into these like high inclination orbits where you have really big angles where you go around the world. You can't really get into those equatorial type orbits. For that, you need a launch site that's near the equator. The nice thing about Cosmic Girl is you can literally fly your plane anywhere in the world. Like you can fly your plane right to the equator and launch fly out of a runway that's near the equator, and you can get onto those on those inclinations that you want to go into. So you have super high flexibility, and you can really address a lot of the payload requirements that some customers have where they want to fly into those interesting kinds of orbits. Here on the screen, again, you can see the altitude of the rocket as it flies. It's just on the left-hand graph there. It's going to be going up as we go in to the next phases of the flight here, as it starts to fly on that free trajectory up to the 500 kilometers apogee target. So keep an eye out for that. Some of the other advantages to launching on a air-launched rocket are, as I had mentioned before, there are some engineering reasons why it's actually better, not just because of the inclinations of the orbit. The first engineering reason is because there's less density higher up in the atmosphere. You can actually have a bigger nozzle that's on your rocket where you expand the gases out to a bigger area, which gives you more velocity of the exhaust gases coming out of the rocket. That can really help because it basically increases the efficiency of your rocket and also allows your rocket to have more thrust for less propellant. So the issue with launching from the ground is that you kind of have to overcome all that pressure that's down lower in the atmosphere, and you can't really build your nozzles as big, and so you get less efficiency. So Launcher 1 can get really high efficiencies out of its rocket immediately just because it's launching from 10 kilometers in the air. The next advantage is that because you're launching from 10 kilometers, you don't have to do work against gravity to get through those first 10 kilometers of flight. Most rockets, when they're launching in the first 10 kilometers, are basically just pointing straight up, and they just launch themselves straight upwards. And for all of those seconds in which they're fighting gravity because they're pointed straight up, those are inefficiencies. So basically, they're losing a lot of energy and fuel to the actual gravity of the Earth, which is not ideal, because we want most of your energy to actually be pushing your rocket sideways so that you can gain enough velocity so that you can get into orbit. So those initial seconds where the rocket's launching straight up are basically, from an orbital perspective, useless for getting you into orbit. Launcher 1 doesn't have to do that because it launches straight up from 10 kilometers, so it has less gravity of Earth to fight, and that can be a huge advantage.
Thank you so much for joining us on today's live stream. Please make sure to follow Virgin Orbit on social media for continuous updates on our successful satellite deployments this evening. We're at Virgin Orbit on Twitter and at virgin.orbit on Instagram.
Excellent. So just one other note, we officially made it to our transfer orbit, but we're not done yet. So we actually have to get to the target orbit to deploy our customer satellite. But that is going to be another 30 minutes. And so like Allison has stated, we're going to be ending our public broadcast now, but make sure to check our social media posts to see the final conclusion to our mission today.
Very exciting conclusion.
Okay, so I guess they're not going to show the deployment of the
We want to thank everyone who tuned in live to watch our Straight Up mission today. We also want to thank all of our customers for flying with us. And a special thanks to the live stream production team, the brand team, and of course, my brilliant co-hosts, Alex and Keith. We look forward to seeing you next time in Cornwall. Bye, everyone.
Maybe the Americans will be able to pronounce the UK names by the time they get to the next launch. So yeah, their next launch will be out of Cornwall, and so yeah, we'll be looking forward to the details of that. If you want to know what happens with the orbital boost and the release of the payloads, you have to go check out the Twitter page of Virgin Orbit. I'm sure they will put updates on what's going on there. It's going to be about 30 minutes away, so you can check out that and follow it just if you're wanting to know the details. Yeah, that's pretty much it for the launch. We had a successful launch of Launcher 1 from Cosmic Girl. The flight was completely nominal. There were no issues at all. And it looks like we are on target for getting those payloads into the orbit they want to go into. The only step left is to, of course, perform that circularization burn at the apogee and then release the payloads. So you can follow that at Virgin Orbit's Twitter page. I think that's going to conclude the broadcast from our side today. If you guys have any other questions, feel free to leave them in the comments. I'll be on for a little while longer, at least in the chat capacity. There's lots of cool things about the rockets that are going up these days, and lots of different vehicles that are available. This is the second successful attempt for Virgin Orbit, so they're looking to be like they're getting some more experience with this launcher, and hopefully it'll be quite a competitive launcher in the future. And I'm really a fan of the air launch platform, just because of the unique advantages that it offers for flexibility, for higher efficiencies in terms of getting payloads into orbit, and also just because of the fact that you don't need to have all the crazy launch costs with respect to operating a launch site. You can kind of fly, as long as you have your plane, you can fly it anywhere and just launch. That is your launch site, is basically the aircraft itself. So there's really interesting opportunities in the future for that. And there's also interesting developments into building bigger air launch systems throughout the world. Definitely check out Strato Launch. They're doing some interesting stuff there as well. Anyways, thanks for joining me today, and I hope that you maintain your curiosity with space stuff and continue to check out all the different types of orbital launch vehicles that are out there today, and definitely root for your favorite one, and Keep the curiosity going. And I hope you remember to keep expanding your horizons.